Hey everybody, this is Larry. This is day 9 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, Jump Game 6. As you can see, I still have to get a new AC. I've just been busy and cheap, so that didn't change. Anyway, in case you wanted to know. Usually I attack these problems live, so it's a little bit slow, fast forward, or whatever you need to do, watch another video. There are more than one ways to learn, so, I support you. You're smart. You'll figure it out. Okay, so today's problem is Jump Game 6. You're given a 0 next nums. Okay. You can jump at most K step forward. Okay, you want to reach, and then the score, you want to get the maximum score jumping 2 at how many times at a time? You can jump from I to I plus 1 to min of I. Okay, so if K is 2, you could go from 1. Well, where do you start? Okay, you can jump from 1 to -1 to 4 to 3. Okay. So I think intuitively, the dynamic programming problem solution, or at least mindset. I don't know if, actually I didn't look at the constraints yet, and oops, what did I click on? But the idea behind some sort of a dynamic programming problem is greedy, right? Which is that, okay, given that I'm in one, let's say I'm just looking at let me put it up here so I could kind of draw on it a little bit better, slightly better. But let's say I'm at 4, right? What does that mean? Well, looking backwards, even though we can go forward, because the naive going forward solution is, okay, for I is from 0 to, or from 1 to K, we get the max score going forward, right? So that's going to be fine. So that's going to be naive. But, I got to stop saying, I don't know who's counting that, but start counting again. But anyway, for this problem, given that n is 10 to the 5th and k is 10 to the 5th, that's going to be n times k, which is 10 to the 10, which is way too slow. So, but the idea still remains is that for each, you can look at it 2 ways. I said it again. You can look at it 2 ways. One is that for each, you could greedy in 2 directions. One is that, okay, you're starting from this position, you kind of look forward and then go to the one that gives you the max score. Or you can look backward to where you're at this step 4. You want to come from the place that gives you the most score, right? And what are the places that you can come from? In this case, it is symmetric in a way, in that for k is equal to 2, that means that if you can go 2 steps forward, you can come from at most 2 steps backwards, right? So that's basically the idea. And then the question is, okay, right? Now we reduce the problem, or change the problem around to say, okay, now we're at a given step. Let me draw an arrow. We're at a given step. We're basically trying to find the max score in the last k elements, and of course that is just, and in that case it's a little bit tricky if you had to do it repeatedly. But notice one thing, right, which is that when you move from this space from 4, let's say we have an answer for 4, but you move from 4 to -7. What does that mean, right? That means that the k used to be from here. This is the range that you're sorting or searching. Sorry. Now when you go to the -7, the range that you're sorting. I said it again. The range that you're searching is really hard, so I'm really easily confused. Clearly, the range that you're searching for, or trying to find the max, goes from here to, sliding over, right, if you will, which hopefully is a hint, which is that you solve that by using sliding window. Unless I misread the problem and I said a lot of stuff unnecessary. Okay. And you're trying to get the max score. In this case, it's going to be greedy because it's just a sum, and sum is, yeah. So that's basically the idea, and that's pretty much it. So let's get started. So DP, yeah. trying to think. Yeah, let's start this by having DP sub. Can it have 0 elements? Nope. Okay. So how do I want to set this up? Okay, let's set length first, and then DP is equal to well, 0 times n, right? 1 for each element of the array, which makes sense. And then we set DP sub 0. Let's see. I mean, basically what we want to do is, and there are a couple of ways to do this, given this sliding window thing. Basically, the key part about the sliding window is that when you slide from here to here, you do two things, right? One is you add whatever the score is here, and two is that you remove whatever score that is there. So that's if you have a sliding window that's a consistent or the same sized window, and in this case you do. So basically you add one, you remove one, so that keeps it okay. And then the question is, okay, how do you get the max score inside that window, right? And of course, in this case, you're going to keep something in different languages. You can do it different ways. You can keep a heap by having like a delayed removal heap, and that will get you most of the way there, or pretty much most of it. It's a little bit weird in certain cases, or you just have to be mindful about the delayedness. So there's one more thing to check, so that you don't always. Well, let me step back a second. Right, using a heap, the thing is that you cannot remove something inside a heap easily in most current implementations of the heap, in the most library implementation of the heap. If you implement your own heap, there is a way you can remove items in a heap, and then you do a reheapify and stuff like that. I'm not going to get into that much, but conceptually you can, but in most library implementation you're going to have to keep track of it. In other languages, for example in Java, I believe you can use something like a tree set or tree map, maybe, or tree multi-set, maybe something like that. I don't know if that's a thing in Java, so you have to look it up. In C++, you would use just a multi-set. In Python, I would use a heap if I didn't have something else, which is a sorted list. And a sorted list is what it sounds like. It is just a list that is sorted, and in this case it allows us to add in log n times, and also add and remove in log n times, and also allow us to get the max element in I think of 1, but maybe I'm wrong on that one. By the way, it's not going to be more than log n, right? So that's basically what I'm going to do here. Yeah, and then now for each item in nums. Okay. Keeping in mind that this sorted list, we are not adding the. Sorry, we're not adding the nums that are inputted in the into the thing. We're not putting the input into the sorted list for the sliding window. Our sliding window is for the scores that we have at those points, right? For example, in this case, we can actually do. Oh, I actually have one here, but okay, fine. Let's do this manually, right? And this is k is equal to 3. The max score at 10 is going to be 10. The max score at -5 is going to be jumping from 10, so it's going to be 5. The max score at -2 is going to be jumping from 10 as well, so it's going to be 8. The max score from 4 is going to be jumping from 10, so it's going to be 14. From 0, it should be from 14, and then 3 is going to be 17. So that's basically the thing here. And our sliding window, of course, here is going to, for example, at 4, we're actually looking at the max of 10, 5, and 8, and not these values here, just to be clear. And at 0, for example, we want the max value of these 3 and not these 3. Okay. So yeah, so now at index we we want to add at the end dp sub index, but we have to process it first, and dp of index is equal to the maximum score of, well, it's going to be num sub, I guess this is just x, plus the maximum score in the list, which is of course the last element in the sorted list is going to be the max score. Of course, this doesn't work for the first element, so let's do here max is equal to 0 if length of 2 is greater than 0, then max is equal to the max out. So that's basically it. As I said, you have to add and remove. So this adds it to the sliding window, but to add it to remove it from the window, we do something like this. If this is greater than k, we remove. Is it remove? I actually don't remember the API, but yeah, what we remove, right? We remove index minus k, and that's basically it. Yeah. And at the very end, we just return the last element of dp, because that is the idea. I mean, we want to end on it, right? Do we have to end on it? Yeah, you want to reach the last index, then yeah. So this is going to be the answer, and that's pretty much it, if I'm correct. If it's not, then I have to do more work. Oh no, spit. Okay, that's fine. Maybe I have something typo e, but. Just see a second. Okay. Let's just print dp out real quick, and then we can audit what went wrong. Okay. So 1. This is going from the last 2. This is going to be 0. That makes sense. This is going to be -1. That's good. 4 can only come from 0. So this is. So I mean. The removing is off by 1. I guess that's why. Why is whoops. If the length. No, it should be right. Right? Now let's print it out real quick. Yeah, so after processing 1 is 0 and 1, and then here we have 3 elements, but that's because we added the last element, so that's okay. Okay, let's do it at conception. Let's do it here. Maybe that's a little bit clearer. Yeah, so no array, then 1, and then 0 1 0. Did I add anything wrong? No. Okay. What is my input? Okay, so 4. At the 4, it should get 0 and -1, or -1 and 0. Why is this wrong? Dong 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 is -1 and 1 instead of -1 and 0. I should remove the 1, but instead. So. Okay. I think I had it off by 1 there. Okay, so that was it. Whoopsie. Very careless recently. But yeah. But this looks okay. These are the things that we said. But yeah. It's off by 1. I just have to be really clear about my indexing. I've been really bad about it lately. Yeah, so this is good. So what's the complexity here, right? Well, essentially, we loop through the array, so that's going to be O of n iterations, and each iteration we do at most 2 add and we move to the sorted list. So that's going to be O of log n. So this is log k, sorry, even. So this is going to be O of n log k, which is at the max it's going to be n log n, but n log k, yeah. And in terms of space, we have two linear space usage here, one for the DP, one for the sorted list. Technically, sorted list is O of k, and you can make this O of k as well if you do something more clever, but essentially, it's going to be linear time, or sorry, linear space and n log k time. That's all I have for this one. Let me know what you think. It's really hard, so I can't really think. I really need to set up at least an AC. I have a heater thing, but it obviously doesn't help with the heat, and maybe I just need more sleep. Anyway, that's all I have. Stay good, stay cool, and I will see you later. And to good mental health, bye bye.